a look at a distance, rate, and time problem. So here's a problem that's going to utilize the fact that, and let's write this down here. This is going to utilize the fact that when we take the rate that something is traveling at, a person, a car, whatever it might be, times the amount of time traveled, we get distance. So abbreviated, we often write rate times time equals d, or d equals r times t. So if we know the rate something's traveling at, we know the time something's traveling at, we can figure out its distance. Turns out, actually, if we know any two of these quantities, we can always find the third. So we'll keep that in mind. So when we come across a problem like this, it says, as a part of an exercise regimen, you walk 6 miles on an indoor track. Then you jog 3 times your walking speed for another 6 miles. This individual is doing 12 miles of exercise. It's a lot of jogging and walking. If the total time spent walking and jogging is 4 hours, find the walking and the jogging rates. So we're given a lot of information, and I like to, when I have a problem like this, I like to organize it because there's so much information and I got to utilize this relationship between rate, time, and distance. I like to organize in what I call a distance diagram. So a distance diagram is simply a way to organize information. Take it out of the words and start putting it into some algebra. So we've got some time walking and some time jogging. We've got the rate at which we do each of those things. We know that if we multiply that by the time spent doing each of those things, we would get the distance. Okay? So notice across the top of my distance diagram, I just rewrote the equation, and each of the quantities I gave a column in this diagram. And then each row is the different type of behavior. So we're walking and we're jogging, and those two things need to be separated because we walk at a different speed than we jog. So now we start to fill things in. It says, as part of an exercise regimen, you walk 6 miles. So I can actually fill that in. So 6 miles on an indoor track. That was the walking. Then you jog at 3 times your walking speed. So 3 times your walking speed. Well, we're not given the walking speed. It's an unknown. So let's call it x. X is the speed, the rate, miles per hour, that we walk. Well, if we jog at 3 times that walking speed, 3 times that would be 3x miles per hour. So I'm just going to make something up. Let's just suppose that we walk at 5 miles per hour, which, by the way, is actually kind of fast for walking. But if we walked at 5 miles per hour, then we would be jogging at 15 miles per hour. Really not a possible speed for jogging or walking, but just so that we can see that algebraic relationship. If we're walking at x miles per hour and we jog 3 times that, we write 3 times x, so 3x. Okay, for another 6 miles. So we also know that we're jogging for 6 miles. Then we're told, and I call this the connecting piece of data, that we're told that the total time, so how are jogging and walking connected? I call this the connecting info. So we'll circle it. It doesn't actually fit into this table because this table has the information separated. So we'll use the information from the table and that connecting info to write our equation. But we're going to do that after we fill in, because notice we've got 2 blanks here in the chart. We don't have the time right now. I'll put a little question mark here. But let's go back to here. If we know any two of these quantities, and in this case we know rate and distance, we could find time, because you could just divide both sides by rate, and time, notice, is distance divided by rate. So time is distance divided by rate, because the relationship is rate times time equals distance. So divide by rate, and you would find that the time spent doing something is going to be the distance traveled divided by the rate that you travel at. So we don't, even though these were blank right here, since the other 2 columns were filled in, we could take the distance and divide by the rate. So time is actually going to be 6 over x. This is in hours, because we're talking about miles per hour and miles and hours walking and hours jogging. And 6 for the jogging, our time is going to be 6 divided by 3x. And again, that's in hours. Okay, so now that we've completed a distance diagram, we've basically taken all the words and we've put them into algebra and numbers. We've put them into this distance diagram in algebra and numbers, utilizing that relationship between rate, time, and distance. Now we're going to go back to that red circle up there, that the total time. So the total time spent walking and jogging. So the time, so here's that connecting info. So connect the information. And we're told that the time, so it's up there at the top, that the total time, which would be the time walking plus the time jogging, has to be equal to the total time spent. Well, the total time spent was 4 hours, so we put in 4 for the total. The time spent walking is 6 over x. And the time spent jogging is 6 over 3x. Now, just as a quick something to notice here, that 6 over 3 could be reduced. So I'm going to go ahead and reduce that because now we can solve this equation for x, which is our time spent walking, or our rate spent walking. So we can go ahead and simplify this. This is just 6 over x. Notice the 6 over 3, that does reduce to 2 over x equals 4. There's a couple of things we could do here. I notice I have a common denominator, so I'm just going to go ahead and add those. So if I add those, I get 8 over x equals 4. Then I can multiply both sides by x, and I would have 8 equals 4x. Divide by 4. And x is 2. And that is in miles per hour. Now, I just want to pause for just 1 second. On this equation where we simplified. Let's just pretend for a second that we didn't simplify. Let's just pretend like we didn't notice that 6 and that 3. Because that's something as a math teacher, I see those sort of things, but sometimes we don't see those things, right? So let's pretend like we didn't simplify that. We left it like this. The other thing that we could do is we could utilize the fact that, or let's just suppose it didn't simplify, because some of these you won't have a simplification where you can find a common denominator as easily as we did here. So if we can't simplify, remember our little trick to take the LCD, which is 3x, and to multiply both sides of that equation by 3x. And I just want to show that we're going to get the same answer, just slightly different steps. When I do that, the x's cancel, and I just get 18 on the first term, because the x's cancel, and then 3 times 6. The 3x's cancel, so I get 6, and then I get 12x. And here I get 24 equals 12x. Divide by 12, and x is 2. So notice that we got the same answer. I just wanted to show another alternative. So, or use LCD to solve the equation. Totally up to you. I always like to show alternate ways to do it if they're easy to show. And that one is a nice, easy little way to show. Okay, so x is 2 miles per hour. So we walk, so that's walking speed. So the walking speed is 2 miles per hour. And then the running speed, or the jogging, use the same language. The jogging speed is 3 times x, so 3 times 2 is 6 miles per hour, 3x. And there's our answer. There's our organization. We use that distance diagram, organize the information, use the connecting information that was given about the total time to write an equation, and then we get our equation, and then we solve it using our methods for solving rational equations.